Imagine a clock that never winds down, a perpetual motion machine that doesn't cheat physics, or a substance that defies the ordinary laws of time. Sounds like something out of a sci-fi blockbuster, right? Well, hold on to your particles because time crystals are real, and they're rewriting the way we understand the universe. First, let's talk about regular crystals, diamonds, salt, and snowflakes. These are solid structures where atoms arrange themselves in repeating patterns in space. Now take that same idea and extend it into time. Instead of just sitting still in a neat atomic formation, time crystals move in a repeating cycle, even without energy input. It's like a cosmic dance that never stops, even in a completely energy-depleted state. Time crystals break something called time translation symmetry. Normally in physics, if you run an experiment today or a year from now, the results should be the same. Time crystals, however, spontaneously change over time in a consistent and repeating way. They oscillate, flipping between states like a metronome that nobody wound up but keeps ticking anyway. This might be because time crystals exist beyond our conventional dimensions. They interact with energy and motion in ways that suggest there's an unseen, higher dimensional framework governing their behavior. 2012. Theoretical physicist and Nobel laureate Frank Wilczek first proposed the idea of time crystals. 2017. Two independent research teams successfully built time crystals in the lab. Boom! Sci-fi just became science fact. Scientists have crafted time crystals using two different approaches. Trapped ions. Line up 10 ytterbium atoms, a fancy metal, zap them with lasers and watch them fall into a stable, endlessly flipping spin pattern. Diamond defects. Inject nitrogen into a diamond's atomic lattice and apply microwaves. These methods hint that time crystals aren't just a quirky quantum oddity. They might be tapping into extra-dimensional forces that we don't yet fully understand. Besides blowing physicists' minds, time crystals could revolutionize fields like their stable repeating states could be used for robust data storage and processing in quantum computers. They offer a new way to study quantum mechanics, many-body physics, and even concepts related to space-time itself. Because time crystals don't require energy input to maintain their state, they could theoretically persist, even after the heat death of the universe. Yep, they could still be ticking when everything else is done. If time crystals are truly interacting with super extra dimensions, they could be the key to unlocking physics beyond the standard model, helping us understand dark matter, gravity, and maybe even the fundamental nature of time itself. But wait, does this mean we can make perpetual motion machines? Not exactly. Time crystals don't generate usable energy, so while they technically move forever, they aren't violating the laws of thermodynamics. No free energy loophole here, folks. Just an incredibly weird and wonderful state of matter. Time crystals are proof that our universe is even stranger than we imagined. They challenge fundamental assumptions about equilibrium, entropy, and the very nature of time itself. They might be the first tangible clue to super extra dimensions. Stay curious. Time crystals still have plenty of surprises up its sleeve.